Hi, everybody. I'm Eric Kaltman, and I'm presenting on organizing a content profile for a large heterogeneous collection of interactive projects, which is, and you can see this, is that me sharing this or not? Did I forget to share? I forgot to share. 1 second. There's where my brain is. Okay, now you can see it. Okay, great. And so this is a long title that literally describes what we did, but isn't really the heart of the work, which I have to work on my paper titles. But this is work done by myself and my students at the Software History Futures and Technologies group at Cal State Channel Islands. And it's a continuation of work that I presented 2 years ago, back in the before times when I could physically see you all. So I'm just going to go over the project background and motivation, and then how the preliminary work from 2019 informs the current work. And then a brief description of the data set and our analysis techniques, and then how that all relates. The work is pretty interdisciplinary and spread out, so I'm going to try and pull it together enough that it's hopefully coherent. My background, right, is that I'm a historian and a computer scientist, and I use data analysis techniques to investigate historical questions around the development of software processes and culture. So how people make software, what systems, what beliefs and such they bring to the development of those systems, how those play out, and how you can find evidence, for that in the records, right? How can you figure out how someone engages in a software development process or an engineering process from the records that you have? And so my general focus is, how, as a historian, do I make effective use of, software development records and production data? And then as a computer scientist, how can I help devise systems that allow me to get to answers to those questions more easily? And so the project data set for this work was kind of serendipitously gathered. I was at a data curation fellow at Carnegie Mellon University Libraries, and I was talking to their Entertainment Technology Center, which is, I think, a world-leading interactive arts master's program. And they offhand mentioned that they had a full project backup that was mildly cataloged for their entire program history over the last 20 years. And then I asked them for it, and they just gave it to me. So I ended up inheriting around 18 terabytes of project prototypes representing essentially like state-of-the-art technologies, in quotes, from the last 20 years, and had to figure out like what we could do with it. And so the original CAS paper from 2019 looked at 4 projects and tried to define a set of basic research questions, as like, how has development work changed over time? What technologies have come in and out of use? How are different types of projects organized, and what can we learn about project organization that will help with historical and archival organizational inquiries? And then what are the implications for the use, resurrection, and big data analysis of production data, right? If I have 14 terabytes of projects of singular provenance that have a bunch of different file formats and all sorts of other stuff, like what types of analysis techniques can I apply to answer questions about this data set? And so this talk is mainly on the second question here, because the current project was an extension of this analysis to characterize the entire data set of 14 terabytes instead of just 4 projects. And so the main goals, right, are to determine what types of records are in the data set so that we can figure out what potential analysis issues we're going to confront, to determine the processes that we use to navigate and organize the information, and how we can embed those processes in future systems. So one of my main methodologies that I go on at a higher level is reflexive analysis of how I'm actually doing the work, to see if there's a way that I can embed the like very hands-on literal stuff that we're doing into potential future systems that can do it for me. And then what can reflexive data exploration support for humanist inquiries, right? If you have a lot of highly varied design collections or production data collections, are these processes transferable to other domains or other disciplines? And so the data set, is a bit unique and kind of odd to have. It's 546 projects over 20 years in 14 terabytes of data. And it's created in their master's program by an interdisciplinary team of, emphatically interdisciplinary teams of artists and engineers. And they work for 14 weeks on each project for a specific, usually industry client. So these are essentially can be effectively thought of as like product prototypes for industry or research institutions or research libraries is who they work with. And so just as a broad characterization of the data set, right? And these are non-exclusive categories, right? There's 267 projects involving gaming, 36 involving animation, 71 physical installations, 78 mobile applications, and 55 virtual reality projects. And of those, 190 involve some aspect of Unity and 87 involve Adobe Flash. And so there's apparently in the, I guess I can say in the graduate school masters of interactive design land, right? Unity and Adobe were the things for the last 20 years. The data organization is actually a working backup and, archive of a very prolific program. So it's basically a huge mess, right? It's not actually an archive, it's just their backup. And it was loosely organized into semester and project folders. And then pre-2006 has this fantastic to be sorted folder, which I think has like 130 projects in it, which is always fun. And sometimes the projects were not grouped by any, like they were grouped by technology instead of chronology, right? So for instance, this picture here is of a Jammo drum, which is a interactive music platform that they developed. And so a lot of the projects affiliated with this specific hardware configuration were grouped together. And so when we tried to find the projects for it, we couldn't locate it chronologically. We had to dive deeper into the project folders. And so the notion of a content profile for this is borrowed from archival analysis work. I don't think it's too well known as a term, but it kind of fit what we were doing when I was doing background. And so essentially what we're doing is aggregating the file metadata for the entire data set to see if we can find trends and interesting stuff in the quantitative analysis there. And so it generally involves using a file identification tool and then outputting the reports from that tool into some database system. And the goals are usually aligned with data preservation and archiving concerns as opposed to historical ones, right? You do this kind of content profile to be like, oh, we have a bunch of really legacy formats in a specific configuration that are going to be harder to retrieve, or, we have a lot of different PDFs of different sizes and we're going to need to, kind of store them somewhere else and think about like the relative amount of data being held by different documentary formats. And so there's a lot of practical archival concerns for this. My use of this is more along historical analysis means of like, what does the content profile show us about how things have developed over time in this collection? And so to characterize this whole set, we essentially started with a qualitative analysis and then switched to a quantitative analysis. And the work here was done heroically by 3 undergraduates that I had working full-time for 2 months over the summer of 2021 to go through all 546 projects and figure out some basic qualitative information about them. And we found out along the way that essentially due to COVID, it's really hard to share 20 terabytes of data easily. So there's a lot of shipping around physical drives and tracking the different data with the different students. The initial thing that kind of came up first was just to figure out which projects we had and what they were about. And it was a kind of, I guess, lucky that there was essentially a canonical listing on the program's website of projects they thought they had done. And so we started with a massive spreadsheet of that, where we just had a project name. And then my students kind of ad hoc developed a process where, since we knew that the program was organized in a specific fashion, you could go to a specific part of each folder if it was present first and search through to find other information about the individual projects. And so we have a bunch of fields that we kind of put together into a very large spreadsheet. And the things that I think are unique for this project and things that kind of caused further questions was we were trying to categorize different types of historical interactive projects based on some open schema, because I'm not aware of any kind of vocabulary for describing how people do computational projects. And even categorizing some of these projects was very difficult due to the constellation of technologies used, right? For example, there is one project, it involves provisioning an application to a Google Daydream headset, and then configuring and coordinating those headset virtual reality experiences with an iPad application that then talks to a remote server, right? So there's like a lot of technologies involved just in that one project. And so defining what all the technologies were, what all the dependencies were, how it would be possible to even reconstruct that experience was, kind of harrowing. And so we did the best that we could in this fashion, right? So there's a technologies listing, which is a broad listing of technical dependencies, and then trying to locate executable file paths in case we wanted to try and emulate or recompile some of these projects for use by ETC to see if they could show this to their current students. And so doing the qualitative work there allowed us to kind of have a structure for describing the individual projects. And so the quantitative analysis proceeded as this essential content profile. So we took the 14 terabytes of data and it turned into a 5 gigabyte database in SQLite, which is just file metadata outputs from Droid. And so Droid is a file identification tool that correlates extension and digital signature information from files with known file descriptions in the pronom database. And so we essentially managed to take the individual project folders that we located for the individual projects and then run a file identification analysis on each project and then combine them into a single unified database. And this process took a bit. We had it running on like my remote server and on multiple virtual machine instances to run Droid in many threads at the same time to kind of get through all the data. And then we aggregated it into a Jupyter Labs notebook for analysis to like query the database. And we're still kind of working on getting that faster because the current database is not really indexed in a way that is useful. So it takes a long time to get the queries to return. So that's kind of the next step here. And so just the basic quantitative results we're kind of illuminating. So there's 9.2 million files in the data set with 4,900 extensions. 3,400 of those extensions were not characterized by Droid. And 36% of the data was redundant across the data sets. And we're basically think that this is because if you're doing a lot of software production work, you end up using the same frameworks and SDKs and things over and over again. And so there's a high amount of duplication across development environments just being copied and pasted across different projects. Bin files were the most prevalent, but not really informative because it's just an arbitrary collection of binary data. And PNGs were the most known format that we found. There's 870,000 PNG files in the data set. The top 4 file formats by aggregate size were all video formats that were mainly uncompressed. So around 7 terabytes of it is just video files that were not managed in a way that was thought of as, this isn't an archive, right? This is just a backup. Yeah, I'll talk about that in a second, Mark. Thank you for the question. We're kind of moving on to that because it took so long to do the Droid analysis. The largest unidentified extension was the Res Unity 3D model archive file format. And there were 1.2 million files that had no extension. And so it didn't know what to do with them. And this isn't actually like a criticism really of Droid and Pronom. It's just that I don't know if a lot of software development stuff actually, or production data for software development kind of gets into these because there's not a lot of this type of data, I think, stored in institutional archives right now. And so as a result of this quantitative stuff, right, we kind of realized that the exploratory analysis, right, was enabled by the contextual information. Like we could make more sense of the data that we were looking at quantitatively by having done this exhaustive work looking through all these project folders and figuring out what's going on. And that my students actually learned about the patterns of data organization used over the course of a project and then developed their own strategies for figuring out how to find more data, right? They became familiar with essentially the data culture of ETC and found it easier and easier to assess certain types of projects that they were more familiar with. I will say though that the another interesting thing here is that the students that were familiar, all my students were familiar with game design projects because they do a lot of game development. And so they could easily look at even a 20-year-old game project and kind of divine the organization of the data based on, you have source code, you have assets, you have specific, silos of information. Whereas when they looked at a computer animation project, they had no idea where to start because they'd never made a computer animation. They don't know how the file structure is organized. And those projects are generally organized based on massive collections of individual scene rendering folders. And I was totally unaware of how the animation discipline even did their stuff until we started looking into this work. Additionally, you can easily track the decline of use of specific technologies, right? Like Adobe Flash precipitously declines in the early 2010s and Unity comes up. And the lived-in backup nature here is also kind of interesting in that there was a lot of like PII and just social information about the projects that I'm pretty sure they didn't realize are actually being stored on their servers. So I've been talking with them about that. And so the notion that you have this kind of living collection of software development production data has been really interesting as far as that. And so, yeah, Droid and Pronom did not really have good coverage for the software development stuff, right? There's around 2,000 permits in Pronom. And memory management was an issue running the multiple Droid processes at the same time, but that was me because I'm a bad computer scientist. And then we need comparative classification from other tools. So the basic thing now that we're going to be working on is generalizing the process we used for the Droid analysis to just be able to plug in Siegfried or other file identification systems and see what they do. Because I figure Siegfried will have may have a way better idea of identifying these things. And then a really funny thing that kind of happened at one point with Droid specifically is that it choked on a set of files and we couldn't figure out why. And then we realized that it was a tar testing library for a node package for node tar that has intentionally included a bunch of incredibly difficult files for parsers to understand. And so this is an example of this, like essentially a historical test set, like fixture breaking our current historical analysis task, which was kind of melting my brain a little bit there. And so I think the implications for this is that if we're getting larger dumps of digital projects and production data in many fields, right, there's going to be this growing issue with figuring out and how to deal with and manage all the massive dependencies and file formats we haven't messed with. And then work from this project is not scalable in this way, right? Like I had 3 students who did this full time for 2 months, right? I think there's got to be ways to automate this type of thing as well. And we need more access to data sets of this type, right? My personal relationship with these people allowed me to get this data set, right? I don't know of other large archives that have massive collections of just software production data that they're going to allow anyone to look through. The closest example I have is talking with people at the Netherlands Architectural Museum, because essentially they get donations of like large architectural firms documents, and that comes inside of a project form as well. And they don't really have any idea what to do with it either, because it's just, you need so much personal understanding of how the development and the production work works. That's good. Oh, thank you, Peter. Yeah, they're using Archivematica. And so next steps, right? Automation of the workflow for arbitrary identification tools. This is similar to the Brunhilde tool that exists. And we actually kind of discovered this after we did this work. So I may see if that can take care of some of the use cases. Further analysis of exploratory methods and categorical analysis of different subsets, right? We have a lot of different types of projects here, and it might be beneficial to like look at only the game projects or only the Unity projects or only the X projects and see if there's certain patterns. And I'm also playing with machine learning and search testing to locate project categories with the notion of maybe there's specific configurations, graph-wise of certain projects historically. And so you could run it, you could train something to, here's a massive data set, find me all the Unity projects. And obviously that might just be searching for a specific file, but there also might be structural things you can look at too. And then we're working on requirements analysis with the ETC directly to see if there's any way to actually leverage the organization of this data set for their needs of the program to show their students what they did. I will also say that the project was really motivating for my students in that they kind of looked into this mess of stuff and then just started thinking about all these ways they have to solve these archival issues, specifically with data redundancy and elimination and Flash project reservation and Unity project analysis and file format profiles, right? So there's a lot of really meaty questions in here about how we deal with software production data and how we analyze it and summarize it for historical study that I think are like very ground level right now. Yeah, and thanks. And I just like to thank my students and definitely open to questions on the continuation of this project, which is not remotely done. Just so much data.